Welcome to chemistry classes. In this video we are going to discuss about mole concept. We are going to discuss about mole concept and different calculation. Okay, so here first we have to understand here relative atomic mass. Already we discussed relative atomic mass. Relative atomic mass means mass of an element or mass of a molecule compared to carbon 12 isotope. Mass of an element or mass of a molecule compared to mass of a carbon 12 isotope. This mass is called relative atomic mass. Magnesium is twice heavier than carbon 12 isotope. Magnesium is twice heavier compared to carbon 12 isotope. So carbon 12 isotope, its mass is 12. So magnesium is twice heavier than carbon 12. So magnesium, relative atomic mass of magnesium is 24. Okay, so here we are talking about mole concept. First we discuss here relative atomic mass in mass of an element compared to carbon 12 isotope. Mass of an element or mass of a molecule compared to carbon 12 isotope, it is called relative atomic mass. Here magnesium is twice heavier than magnesium is twice heavier than carbon 12. So here relative atomic mass of magnesium is 24. Okay, when you compare mass of an hydrogen, you can see mass of hydrogen is 1 by 12 compared to carbon 12 isotope. Compared to carbon 12 isotope, hydrogen is 1 by 12 heavier. Okay, so 1 by 12 heavier than carbon 12 isotope. So relative atomic mass of hydrogen is 1. Relative atomic mass of hydrogen is 1. Okay. Similarly here we have to understand here when you consider here relative atomic mass of carbon 12, it is 12 gram because it contains exactly 6 neutron and 6 proton. Okay, so here mass of carbon 12, it is 12. Okay, similarly here mass of relative atomic mass of magnesium is 24. So here we can say number of atoms in 12 gram carbon, also number of atoms in 24 gram of magnesium will be same. Relative atomic mass of carbon is 12. Relative atomic mass of magnesium is 24. Okay, so when you take 12 gram carbon and 24 gram magnesium, you can see number of atoms will be same. Number of atoms in 12 gram carbon, 24 gram magnesium will be same. Clear? So here one more substance means substance it contains number of atoms similar to or same as number of atoms in 12 gram carbon 12. Okay, so here one more substance mean that substance contain number of atoms same as number of atoms in 12 gram carbon 12 isotope. One more substance and 12 gram carbon 12 isotope contain same number of atoms. You have to understand one more substance and 12 gram carbon 12 isotope both contain same number of atoms. So one mole magnesium or one mole hydrogen, one mole water, anything it contains same number of atoms like in 12 gram carbon 12. Everything one mole substance it contains same number of atoms like here 12 gram carbon 12 isotope. Okay, next one we have to discuss here Avogadro constant. Avogadro constant. Italian scientist Avogadro found that 12 gram carbon 12 isotope which contain this much number of atoms. 12 gram carbon 12 isotope, it contain 602. After 602, 21 zeros. This huge number, we cannot count this huge number. This much number of atoms are present in 12 gram carbon 12 isotope. Italian scientist Avogadro found this. Okay, shortly we can write 6.02 10 power 23. Okay, 12 gram carbon 12 isotope which contain this much number of atoms, and this number called Avogadro constant because this discovery did by Italian scientist Avogadro. Okay, that's why this number is called Avogadro constant. 12 gram carbon 12 isotope contain 6.02 times 10 power 23 particles. Okay, we discussed before 12 gram carbon 12 and 24 gram magnesium, it contains same number of atoms, and they are 1 mole substance. Okay, 1 mole substance means 24 gram magnesium, it is 1 mole substance because it contains same number of atoms such as like 12 gram carbon 12. 12 gram carbon 12 and 24 gram magnesium both contain same number of atoms. Now we discuss Italian scientist Avogadro found that 12 gram carbon 12 it contains 6.02 into 10 power 23 particles. So how many particles will be, how many atoms will be there in 24 gram magnesium? Look here, 12 gram carbon 12 and 24 gram magnesium, okay, they contain same number of atoms. Now here we are saying Italian scientist Avogadro found that 12 gram carbon 12 contains 6.02 into 10 power 23 atoms. So you can say here 24 gram magnesium also contains 6.02 into 10 power 23 atoms. Clear? Similarly, look here, you can say here 23 gram sodium. You can check your periodic table, you can see relative atomic mass of sodium 23. Relative atomic mass of sodium 23. So 23 gram sodium, you take 23 gram sodium, it contains same number of atoms. 6.02 into 10 power 23 atom. Okay, similarly you take hydrogen. Hydrogen, relative atomic mass of hydrogen 1. Okay, so relative atomic mass of hydrogen 1. So when you take 1 gram hydrogen, it contains 6.02 into 10 power 23 atoms. Look here, water molecule. Relative molecular mass of water H2O. Oxygen 16, hydrogen 1. Here 2 hydrogen, 2 times 1 plus 16, 18. Mass of water molecule 18. Okay, relative molecular mass of water 18. So when you take 18 gram water, it contains 6.02 into 10 power 23 molecules. Okay, here it is molecule. So we will say here when you take 18 gram water, it contains 18 gram H2O. So it contains 6.02 into 10 power 23 molecule. Okay, and this is 1 mole substance. Here it is 1 mole substance. This is also 1 mole substance. So you want to take 1 mole oxygen molecule. So how much mass you have to take? You want to take 1 mole oxygen molecule. You want to take 1 mole oxygen O2 molecule. So how much mass you have to weight? Here oxygen atomic mass 16. So here O2 means 2 times 16, 32. So 32 gram oxygen molecule contain 6.02 into 10 power 23 molecules, and it is 1 mole substance. Clear? you want to take 1 mole helium. Helium, it is monoatomic, He, not He2. Helium, it is monoatomic. You want to take 1 mole helium. So how much mass you have to take? Helium. Helium, it is relative atomic mass of helium, it is 2. So you have to take 2 gram helium. 2 gram helium, it contains 6.02 into 10 power 23 atoms, and it is 1 mole substance. Okay, so here 1 mole substance is obtained by weighing out its relative molecular mass or relative atomic mass of given substance. Okay, you have to take 1 mole substance. Okay, you want to measure 1 mole substance of a sample, so you have to check its relative atomic mass or relative molecular mass. Based on this, you have to measure its weight. Okay, for example, you want to take 1 mole oxygen molecule. So what is the relative molecular mass of oxygen molecule? 32. So you have to take 32 gram oxygen to get 1 mole oxygen molecule. You want to get 1 mole helium. Helium, it is monoatomic, relative atomic mass of helium 2. So you have to take 2 gram helium. You have to take 2 gram helium to get 1 mole helium. Okay, so here another water. You want to get 1 mole water molecule. So here relative molecular mass of water 18. So take 18 gram water molecule. 18 gram water molecule, it contains 6.02 into 10 power 23 molecule. It is 1 mole substance. Here I told you 32 gram. 32 gram oxygen, it is 1 mole substance. It contains 6.02 into 10 power 23 atoms. Here 2 gram helium. 2 gram helium, it is 1 mole helium. It contains 6.02 into 10 power 23 atoms. Okay, so this is Avogadro constant. Okay, based on this, we have some calculation here. Okay, to solve this calculation, we have to remember this equation. Number of moles is equal to mass of substance, mass of given substance divided by relative atomic mass or relative molecular mass. Okay, here we have some calculation. To solve this, we have to remember this. Number of moles, N represent number of moles. Number of moles is equal to mass of given substance divided by relative atomic mass or relative molecular mass. Okay, so you can say here number of moles is equal to mass divided by molar mass or mass divided by relative atomic mass. Using this, you can find mass. Mass of the substance is, rearrange the equation. Mass of the substance is number of moles times molar mass. So remember this equation. Okay, based on this, we can simply calculate this. Number of moles is equal to mass divided by molar mass. See here one question. Calculate mass of 0.5 moles of bromine atom. Okay, so you can use your periodic table and you can see relative atomic mass of bromine is 80. Relative atomic mass of bromine is 80. Also here given 0.5 moles. 0.5 moles. So here N is equal to 0.5. N means number of moles. 0.5 moles. So N is equal to 0.5. So here question asking calculate mass. Mass mean M. You have to calculate M. So mass is equal to number of moles times molar mass. Okay, mass is equal to number of moles times molar mass. So what is number of moles here? Number of moles is 0.5. And what is M? Here it is atom, so you have to use here AR, relative atomic mass. Relative atomic mass of bromine is 80. So answer will be 40. Okay, it is mass, so here 40 gram. So this is answer 40 gram. Okay, Next question here, calculate mass of Br2. Br2 means bromine molecule. Okay, bromine molecule, here it is given 0.5 moles. Okay, so here also you have to find mass. Mass is equal to number of moles times relative atomic mass. Okay, so here number of moles is already given 0.5 times here Br2, 1 bromine it is 80. So Br2 means 2 bromine, so it will be 160. So here answer will be 80 gram. Okay, 0.5 times 160 means half of 160, so it is 80 gram. So simply you can calculate using this equation. See here, based on this another question here, how many moles of oxygen molecules are there in 64 gram of oxygen molecule? Here how many moles? Here you have to find number of moles. Okay, number of moles. And here 64 gram mass is given. Mass is 64. Okay. So here oxygen molecule. So you have to find here number of moles. Number of moles is equal to mass over molar mass. Mass is given 64. Divided by relative molecular mass of oxygen. Oxygen 16. So O2 means 16 times 2. So it will be 32. So molecular mass of oxygen is 32. So after solving 64 divided by 32, you will get 2. So answer is 2 moles. Okay, 2 mole. So simply you can calculate, you can find number of moles, you can find mass using this equation. Number of moles is equal to mass over molar mass. If the given substance is molecule, you have to use number of moles is equal to mass over molar mass. If the given substance is atom, so you have to use number of moles is equal to mass over relative atomic mass. Clear? Okay, next one we have to discuss here some calculations based on balanced chemical equation. Okay, we have to discuss here some calculations based on balanced chemical equation. See here one balanced chemical equation. Carbon reacted with oxygen formed carbon dioxide. Carbon reacted with oxygen formed carbon dioxide. So here from this equation we can say 1 mole. See here the ratio of carbon. Here 1 carbon, 1 oxygen, 1 carbon dioxide. Sometime you can see here N2 plus 3H2 giving 2NH3. This is one balanced chemical equation. Here 1 nitrogen, here 3 hydrogen, here 2 NH3. So here the coefficient of nitrogen is 1, coefficient of hydrogen is 3, coefficient of NH3 is 2. Similarly here coefficient of carbon 1, coefficient of oxygen 1 and carbon dioxide 1. So this coefficient helps to understand moles. Okay, here 1 mole carbon reacted with 1 mole oxygen form 1 mole carbon dioxide. Similarly here we discussed 1 mole carbon mean its mass 12 gram. Okay, similarly 1 mole oxygen molecule mean its mass 32 gram. 1 mole carbon dioxide mean 44 gram. We already discussed this. Here atomic mass, relative atomic mass of carbon is 12. So 12 gram carbon mean it is 1 mole. Okay. And here oxygen molecule, oxygen, relative atomic mass of oxygen 16. Oxygen molecule mean 32. So relative molecular mass of oxygen molecule 32. So 32 gram oxygen molecule mean 1 mole. Clear? Similarly here carbon dioxide, relative molecular mass here carbon dioxide, carbon 12, oxygen 16. So 12 plus 16 times 2, so 44. Relative molecular mass of carbon dioxide 44. So 44 gram carbon dioxide mean 1 mole. 44 gram carbon dioxide mean 1 mole. So look here, here coefficients are 1, 1, 1. So here using this coefficient we can say number of moles of carbon 1, oxygen 1, carbon dioxide 1. So 1 mole carbon mean 12 gram, 1 mole oxygen molecule 32 gram, 1 mole carbon dioxide mean 44. Okay, so you can say 12 gram carbon reacted with 32 gram of oxygen form 44 gram carbon dioxide. Clear? So using this we can say here 12 gram reacting with 32 form 44 gram. So we can say using ratio. See here 6 gram carbon reacted with 16 gram oxygen form 22 gram carbon dioxide. Same ratio 12, 32, 44. We divided with all this divided with 2. So 6, 16, 22. 6 gram carbon reacted with 16 gram oxygen molecule form 22 gram carbon dioxide. Okay, so here this its ratio this one. So using a balanced chemical equation, this balanced chemical equation helps to understand number of moles of reactant and product. Also it helps to understand mass of reactant and product. So always a balanced chemical equation, it helps to understand number of moles of reactant and product. Also it giving information the mass of reactant and product. Using this moles we can find mass or mass ratio. Okay. So here one more thing, look here 12 gram carbon reacted with 32 gram oxygen form 44 gram carbon dioxide. So here you can see 12 plus 32 44. Okay, as we discussed before, here mass of reactant will be equal to mass of product. So mass do not change during chemical reaction. Mass of reactants always equal to mass of product. They do not change. Clear? Okay, so here we discuss using balanced chemical equation we can find number of moles and mass of reactant and product using balanced chemical equation. So here we have to follow some steps to find mass of reactant and product. To find mass of reactant or product, we have to follow some steps. First one, we have to write here balanced chemical equation. First step, write the balanced chemical equation. Then we have to write down relative atomic mass or relative molecular mass. Depends on the chemical equation. First we have to write balanced chemical equation. Then we have to write relative atomic mass of reactant and product or relative molecular mass of reactant and product. Depends on the situation. Okay. For example here carbon plus oxygen giving carbon dioxide. So here we have to write 12, here 32. So here carbon it is relative atomic mass. Here O2 it is relative molecular mass. So depends on the situation we have to write relative atomic mass and relative molecular mass. Clear? So first step we have to write the balanced equation, then we have to write relative atomic mass or relative molecular mass, Then third step, this relative atomic mass or relative molecular mass, we have to write them in gram. Okay, so here first step, write the balanced equation, then write down their relative atomic or relative molecular mass. Okay, carbon dioxide 44. Then write this relative atomic mass or relative molecular mass in gram. Okay, so here 12 gram, here 32 gram, here 44 gram. Clear? Then here find the actual mass. So here balanced equation, we have relative atomic mass. Okay, then we wrote it in the gram. Then using this equation, number of moles is equal to mass over molar mass. Using molecular mass and number of moles, we can find the mass of reactant and product. Okay, we know the equation, we discussed already. Number of moles is equal to mass over molar mass. So rearrange this equation. Mass is equal to number of moles times molar mass. Okay, so using this equation, we can find mass. Okay, using number of moles and molecular mass, we can find mass. Okay, based on this, we have one question here. Hydrogen burns in oxygen to form water. What mass of oxygen used for 1 gram hydrogen? Hydrogen, after burning it producing water. Okay, here we have to find mass of oxygen used. Mass of oxygen used for 1 gram hydrogen. You have to find mass of oxygen reacted with 1 gram hydrogen. Okay, so here using this statement, we have to write first this type of balanced equation. Hydrogen burns in oxygen to form water. So hydrogen reacting with the oxygen forming water. So what is the equation? 2H2 plus O2 giving 2H2O. 2H2 plus O2 giving 2H2O. This is balanced equation. What is next step? Then we have to write relative atomic mass or relative molecular mass. Here hydrogen, relative atomic mass of hydrogen 1. Here, okay, look here. We have to write the mass of 2H2. So we know mass of 1 hydrogen is 1. So see here 2. So 2 times. Here H2. So 1 times 2. Clear? Here 2H2. H2 its mass is 2. 1 times 2. That's why here H2. Again there is 2. Why again 2? Because 2H2. So here the mass will be 4. 2H2 mass is 4. Clear? And here oxygen O2. 1 oxygen 16. 16 times 2, 32. Here we know here mass of water 18. 16 plus 2, 18. Here 2 water molecules. So 2 times 18, 36. So this is the relative atomic, here all relative molecular mass. So here these are the relative molecular mass for 32, 16. Next step, we have to convert them in gram. 4 gram, 32 gram, 36 gram. Okay, so look here, the question asking here, what mass of hydrogen reacting with 1 gram hydrogen? Here using this you can see 4 gram hydrogen reacting with the 32 gram oxygen. 4 gram 32, 4 gram hydrogen reacting with the 32 gram oxygen. The question asking the mass of hydrogen and oxygen. Here 1 gram hydrogen reacting with what mass of oxygen? This is you have to find. You have the information 4 gram hydrogen reacting with the 32 gram oxygen. Okay, so you need here 1 gram hydrogen. So when you divide 4 with 4 divided by 4, it is 1. Clear? We know this information: 4 gram hydrogen, 32 gram oxygen, 16 gram H2O. You need 1 gram hydrogen, 1 gram hydrogen. So you have to divide 4 divided by 4. 4 divided by 4, that is 1. Okay, so you have to divide all this number with 4. Okay, 4 divided by 4, 32 divided by 4, 36 divided by 4. So you will get 1 gram hydrogen reacting with 8 gram oxygen. So that is the answer. That is the answer. 1 gram hydrogen reacting with 8 gram oxygen. So what product form? Here the product 9 gram water will be formed. Here not asking product, here asking about the mass of oxygen. What mass of oxygen reacting with 1 gram hydrogen? So here 8 gram oxygen is reacting with 1 gram hydrogen. Clear? So this way. Okay, based on this we have one more question here. Here question saying iron reacted with a solution of copper 2 sulfate to give copper and a solution of iron sulfate. So here using this question giving some information: 1.4 gram iron reacting with 1.4 gram iron reacted with some aqueous solution of copper form 1.6 gram copper. So using this information we have to write a balanced equation for this reaction. I will read the questions once again. Iron reacting with okay, 1.4 gram iron reacted with aqueous copper sulfate. Here aqueous iron sulfate and 1.6 gram copper formed. This is the information from the question. Here iron sulfate formed. Okay, so write down the balanced equation. What is the balanced equation? Also here using periodic table you will get relative atomic mass of iron 56, relative atomic mass of copper 64. Okay, so you have to write balanced chemical equation. So how can you write this balanced chemical equation using this information? This we have to check now. Okay, so here you know that mass of iron and mass of copper. So using this you can find number of moles of iron and number of moles of copper. So number of moles of iron is 1.4, mass divided by atomic mass. You know the equation to find number of moles. Number of moles is equal to mass divided by relative atomic mass. So mass is given in the question, it is 1.4, 56 relative atomic mass. So its number of moles is 0.025. Similarly here number of moles of copper 1.6 divided by 64, 0.025. Okay, so here number of moles of iron and number of moles of copper. Number of moles of iron and copper both are same, 0.025. Okay, so check this number carefully and you can see here 0.025, 0.025 when you divide with same number. When you divide these two numbers with a common number 0.025, you will get here 1, 1. So the ratio of iron and copper is 1:1. Okay, 1:1. This is the ratio. Ratio of iron and copper 1:1. Here we found the number of moles of iron and copper same number, so we can divide and we will find its ratio 1:1. Okay, so look here, iron reacting, this is the equation. So iron reacting with aqueous copper sulfate, copper and iron sulfate formed. So you know there are two different type of iron, Fe2 plus and Fe3 plus. Two oxidation state for iron, Fe2 plus and Fe3 plus. So there are two possibility to get FeSO4 and Fe2SO4 twice. SO4 2 minus Fe2 plus. So the formula will be FeSO4. Clear? Another possibility, Fe3 plus SO4 2 minus. Okay, so here it is 3 and here it is 2. So Fe2SO4 twice FeSO4. These are the two possibility for iron sulfate. So here the question saying these are the information from question. 1.4 gram iron, 1.6 gram copper, and we found their number of moles and we found their mole ratio iron and copper 1:1. So here we know 1 iron giving 1 copper. Okay, so here to balance this equation you must write here 2 iron. Okay, so here the ratio of iron and copper 2:1. Here 2 iron giving 1 copper. But according to this equation 1 iron giving 1 copper. So you can write here balanced equation. Iron reacted with aqueous copper sulfate giving copper and iron sulfate. Okay, 1 mole iron giving 1 mole copper. Clear? So this is the balanced equation. Iron reacted with the copper sulfate formed copper and iron sulfate. And here we know iron, it is solid state, copper sulfate solution, so it is aqueous state, copper formed copper, it is solid state, iron sulfate solution, so it is aqueous state. Okay, so in aqueous something in solution we have to write it in aqueous state. Okay, so this is the balanced equation and it is not answer. This is the correct answer. What is the reason? Because here iron and copper 1:1 ratio, so this is the correct equation. Clear? So these are the things we have to discuss in this video. Rest of the things we will discuss next video. Okay, so watch next video. So thank you for watching this channel.